again, it depends on what level we're talking about. So at a kind of operating system level, so my background's in chlor-alkali. So one of the things we used to track very carefully was cell voltage rate rise, and effectively the pounds per ton to manufacture chlorine. And many of the hydrogen water electrolyzer operators do very similar things. Because the cell voltage tells you where you are, tells you how much your cost of hydrogen is, and the degradation rise rate, ultimately says whether you've got a steady state sort of degradation going on, or whether you are in some sort of catastrophic failure mode where you've got exponential increases, which you then have to do something serious about. So at a system level, those are the sorts of things. What we're doing at the moment in terms of materials characterization, let's say ex situ, so where we're trying to develop representative and relevant ASTs, accelerated stress tests, we do quite a lot of work to probe the surface properties. So we will do some conventional corrosion measurements, those in the audience that know, but linear sweep voltammetry to measure things like the fundamental corrosion current and the fundamental corrosion potential. They tell us a lot about the surface chemistry and the surface condition that we are then correlating with in situ performance, both at small scale, stack, and system level. So we're getting that kind of crossover across the scales of technology play. And those are things, again, everybody at the moment, unfortunately, does things a little bit different. So we might have 10 ppm of fluoride added to that condition. We might operate a potential of 2.2 volts against hydrogen. Other people might have 15 ppm. They might operate at 1.82 volts. So it's actually sometimes quite difficult to get a cross comparison of those key ex situ parameters. But we're working closely with our customer base to do exactly that, so that when we measure one thing and they're measuring it, we're measuring something similar. So we get a proper cross comparison. And then, of course, again, similarly at small lab scale tests, 5, 10, 25 square centimeters, cell voltage is critical, degradation rate is critical. Repeated measurement of things like polarization curves are extremely informative to be able to be diagnostic about any changes that are being seen in the cell voltage performance. So you're looking at there whether, as Gurjant said, catalyst degradation appears in a different region of the polarization curve to some of the more straightforward resistive components, and you can be slightly diagnostic about that. And then another really interesting technique, which I like a lot, is to have one of these small lab cells and put on a high frequency impedance, high frequency resistance measurement system, where you're taking out all the non-ohmic components, and that's exactly what you're looking at. So things of membrane resistance, the metal resistance in the titanium components and the interfaces, coupled with the resistances in the cathode side GDL, for instance. And again, you can therefore be diagnostic whether your degradation is being caused by membrane failure, by something in the titanium components or the GDL, or whether it's at the catalyst level. And again, correlating the operating environments, operating experiences to those sorts of changes can be really, really instructive. So those are the things that we do and are doing increasingly, and certainly a lot of people seem to be doing that out in the wider world as well. I think there's some fantastic work being done on current distribution modeling as well, I have to say, where we're looking at that, the impact of those porous transport layers and how they can help with making the current distribution at the membrane surface, the anocatalyst layer, as uniform as possible. Again, linking that back to performance is a really neat piece of work that's going on in various laboratories. So there's quite a few things, but fundamentally it comes down to measuring some of the basic electrochemical cell performance characteristics that are well tried and tested.
Thanks, David. And Gurjant, I'd like to open this up to you as well on your AEM side of the fence. Is it much the same for you? Are there any other different kind of metrics or calculations on your side?
No, I think it's the same. I mean, that's exactly what we use. However, our focus is always in situ. I mean, we try to take the cell level, the level of the testing scale is always similar to our actual product in the field. So for example, we of course we do 5 centimeter scale, 25 centimeter scale, but we focus on large scale systems, 100 centimeter scale. Again, I mean, it's almost the same, but again, for us, we work with a lot of universities, when it comes to nanoscale measuring and all that stuff. But as a system developers, as stack developers, we really focus on testing on bigger scale. 50 kilowatt system, the whole system, generating the same curves and comparing them with the small scale cell. But yeah, I mean the method is same as David described, and we check for all these things to make sure our system is kind of the small levels versus the bigger scale are linear or similar.